So today we'll start with irrational inequalities. Now there are certain things that we must know before we can start solving irrational inequalities. The first thing is, if I see any expression with a square root under root fx, so I must know two things. Now the first thing is, since it's a positive square root, its sign doesn't change, so it'll always be positive. And the second thing is, its domain. So that is, this function fx cannot take all the values. This function can take the values only when fx is greater than or equal to 0. X minus 1 under root of x square minus x minus 2, and this is greater than or equal to 0. Now in this inequality, I see a polynomial expression and an irrational expression. So first thing I'll do is, I'll find the domain of this expression. So I can write it as x square minus x minus 2 greater than or equal to 0. X plus 1, x minus 2 greater than or equal to 0. So here I'll get minus 1 and then 2. So plus, minus and plus. I'll need plus. So domain of this function is either x is less than or equal to minus 1 or x is greater than or equal to 2. Now I'll solve this inequality. Now when I see this square root sign, I know it's a positive square root. Now it's a positive square root, its sign doesn't change. So rule number 1 says, if there is any expression whose sign doesn't change, I'll remove the expression from the inequality, keeping the sign. So I'll write x minus 1 greater than or equal to 0, x is greater than or equal to 1. So x is 1 or greater than or equal to 1. Now because it has an equality sign, so with rule number 1 comes rule number 3. And rule number 3 is, I will add the roots of the expression which I have removed in the final solution. So what are the two roots? The two roots are x equals minus 1 and x equals to 2. Now 2 is already included, right? So all I need to do is, I'll just need to add one more point, and that is x equal to minus 1. So now in order to write the final solution, I need to take the intersection of the inequality condition with the condition of domain. So one way of doing it can be, I can take up a number line and I'll represent both the solution on the same number line. So the first solution is, x is either minus 1 or greater than or equal to 1. And the second solution is, either x is less than or equal to minus 1 or x is greater than or equal to 2. Now when I look at these two conditions, so I need to find the points or the interval where both the conditions exist simultaneously. So both the conditions exist simultaneously in this interval, that is from 2 to infinite, and also at this point at x equal to minus 1. At x equal to minus 1 also both the conditions exist. So that means answer to this question will be, x belongs to this one point which is minus 1 and then union included 2 to infinite. So this is how we solve such questions. Say for example, x minus 1 upon 3 minus x is greater than minus 2. Now first thing, what is the domain of this function? Domain of this function is x minus 1 upon 3 minus x should be greater than or equal to 0. So the roots are 1 and 3. So plus and minus, so it will be minus. Minus, plus and minus. I need what? I need plus. So from 1 to 3. Now because it's a rational inequality, I'll include the roots of numerator because there is an equality sign. And I'll exclude the roots of denominator. So that is, the domain of this function will be between 1 and 3, 1 included and 3 not included. So I'll come back to this inequality. So in this inequality, the left hand side is positive and right hand side is negative. So positive number is always greater than a negative number. So it will always be true provided the condition of domain is satisfied. So answer to this question itself is, x belongs to included 1 to not included 3. So another condition which is very important in irrational inequalities is, under root of x, suppose greater than a. Now depending on this A, whether A is negative or A is positive. Now when I look at this condition, under root x greater than A, under root sign positive square root and A is negative. So a positive number is always greater than a negative number. Now what if when A is positive? So when A is positive, if I write under root of x is greater than A, so left hand side is positive and right hand side is positive. So in order to solve this question, what I can do is I can actually square it. So if I'll square it, I'll get what? I'll get x is greater than A square. So this is how we'll solve it. So when I have a positive number and a negative number, then the case is very trivial. But when I have both the numbers which are positive, so I can simply square them to solve it. Now the questions which are more interesting in irrational inequalities are the kind of questions such as under root of x square plus x minus 12 and this is less than x. So the question is, I need to solve under root of x square plus x minus 12 and it should be less than x. Now when I see expression within square root, first thing what I'll do is I'll find its domain. So its domain will be x square plus x minus 12. It should be greater than or equal to 0. X plus 4, x minus 3 is greater than or equal to 0. Minus 4 and 3 plus minus and plus less than minus 4 or greater than 3. So domain of this function is either x is less than or equal to minus 4 or it is greater than or equal to 3. Now we'll come to solving this inequality. Now in order to solve this inequality, I have to take two separate cases. Now case 1, when this expression of the right hand side x is less than 0, and case 2, when this actually, so case 2, when right hand side is actually greater than or equal to 0. Now when I look at the first case, when x is less than 0, the condition I'll get is under root of x square plus x minus 12 is less than x. So what I see here is there is a positive expression on the left hand side and a negative expression on the right hand side. So positive number is less than a negative number. So there is no solution to it. A positive number cannot be less than a negative number. So first case, we don't have any solution. Now what about case number 2? So for the second case, when x is greater than or equal to 0, what I'll get is under root of x square plus x minus 12 is less than x. So I'll simply square x square plus x minus 12. Now since both of them are positive, I can simply square it. Is less than x square. So what I'll get is x is less than 12. Now this result, it has come with the condition, and the condition is this is only true when x is greater than 0. So that means these two conditions, they must be simultaneously true. The result I'll get is the value of x should be greater than or equal to 0 but less than 12. So from the two cases, the condition I'll get is the value of x should lie between 0 and 12, and the condition of domain is either x should be less than or equal to minus 4 or x should be greater than or equal to 3. So now I'll need to take the intersection of these two conditions. So I'll take up a number line, and on this number line I'll mark both the conditions. Less than minus 4, greater than or equal to 3, and the second condition is the value of x lies between 0 and 12. So included 0 and not included 12. So the interval where both the conditions exist simultaneously is between 3 and 12. So here I'll get x belongs to, so from 3 to 12, 3 included and 12 not included. Now the first thing that I'll do in this question is to find the domain of this function. So in order to find domain, I'll write x square minus 2x should be greater than or equal to 0. X minus 2 should be greater than or equal to 0. So this is 0 and 2 plus minus and plus, I need plus. So value of x should be either less than or equal to 0 or greater than or equal to 2. Now again, since I have this polynomial expression, I'll take two separate cases. Case 1, when 4 minus x is less than 0, or case number 2, when 4 minus x is greater than or equal to 0. So, which is when x is greater than 4, or when x is less than or equal to 4. Now, when I look at the first case, I'll write 4 minus x is less than under root of x square minus 2x. Now, 4 minus x is negative, and x square minus 2x is a positive square root. This value is positive. So, 4 minus x is less than 0, negative, and it's a positive square root. This value is positive. So, positive number is always greater than a negative number. So, that means this is always true. But then this result, it comes with the condition that the value of x should be greater than 4. So, the result that I'll get here is the value of x should be greater than 4. So, from the first case, the result I have is the value of x should be greater than 4. Now, I'll come to the second case. Now, in the second case, when x is less than or equal to 4, the condition I have is 4 minus x is less than under root of x square minus 2x. Now, left hand side is positive and right hand side is also positive. So, what I can actually do is I can actually square it. So, if I'll square, I'll get what? 16 plus x square minus 8x, x square minus 2x. I can cancel x square. So, if I'll take it on the right hand side, I'll get 6x is greater than 16. I get x is greater than 8 by 3. So, the result I have got is x is greater than 8 by 3. Now, this result, it comes with a condition, and the condition is value of x should be less than or equal to 4. So, that means I have to take intersection of these two conditions. So, I need to find the values of x which are common to both of them. So, from here, the result I'll get is x should be greater than 8 by 3 but less than or equal to 4. So, from these two conditions, the result I'll get is x should be greater than 4 or x should lie between 8 by 3 and 4, and with it I'll also need to take care of its domain component. So, finally I'll write the answer. So, now because in this case, in these two cases there is an OR, so I'll take a union of both the cases. It lies between 8 by 3 and 4. So, when I see here, I see this number 4, so actually I can combine it. So, I can actually write this as x belongs to 8 by 3 to infinite, because 4 is corrected in the two intervals, right? So, I can simply write this as x belongs to 8 by 3 and infinite. And finally, I need to take intersection of this condition and its domain. So, what I'll do is I'll write it as x is from 8 by 3 to infinite, not included, and the condition of domain is less than 0 or greater than or equal to 2. So, the interval where both the values exist simultaneously is this interval. So, the result I'll get is x belongs to 8 by 3 to infinite. So, answer to this inequality is x belongs to 8 by 3 to infinite. So, now these kind of questions, they are a little complicated. The first thing that we have done is we have to find the domain of this function, and then we'll keep it aside, we'll use it in the end. And then for this polynomial expression, we have to take two separate cases, case 1 when this is negative and case 2 when this is positive. So, when this is negative, left hand side is negative, right hand side is positive. So, this is always true provided the given condition, which is x is greater than 4. So, from this first result, I'll get this condition as x should be greater than 4. Now, when 4 minus x is positive, so I can simply square it and solve it. I'll get a condition which is x should be greater than 8 by 3. Now, this result, it has come with the condition that x should be less than or equal to 4. So, I'll take the intersection of these two conditions. So, when I take the intersection, x is greater than 8 by 3 but less than or equal to 4. So, the result I'll get is 8 by 3 is less than x is less than equal to 4. Now because it's an or between the two conditions, I'll take a union of these two. So when I take a union, so it says from 8/3 to 4 and then from 4 to infinite. So together I can write it as from 8/3 to infinite. Now finally I'll take the intersection of this result and this domain condition, and the final result I'll get is the value of x should be greater than 8/3. So answer to this inequality is from 8/3 to infinite. So this is how we solve irrational inequalities. Thank you.
First, I see two square root expressions, so I need to find domain of both. So for this one, domain will simply be x plus 1 should be greater than equal to 0. That is, x is greater than equal to 1. And for this one, it will be 3 minus x should be greater than equal to 0. X is less than or equal to 3. So first, I'll find the domain of both the functions. Now I'm going to solve the inequality. Now since both the expressions are positive, so I can simply square it. I'll get x plus 1 is greater than 3 minus x, so I'll let 2x is greater than 2. I'll get x is greater than 1. So now I'll take the intersection of all the three conditions. So the first condition is x should be minus 1 or greater than minus 1. Second condition is x should be greater than 1. And third condition is x is 3 or less than 3. So all the three conditions exist simultaneously in this interval. So answer to this question is x belongs to, so not included 1 to included 3. So I'll take another question, and the question is x minus 2 upon under root of 2x minus 3 minus 1, and this is less than 4. The first thing again I'll do is I'll find its domain. So for its domain, 2x minus 3 should be greater than or equal to 0. That is, x is greater than or equal to 3/2. Now I'll multiply the numerator and denominator with its conjugate. So I'll multiply numerator and denominator with 2x minus 3 plus 1. So when I multiply numerator and denominator, I'll get x minus 2 into under root of 2x minus 3 plus 1. And here when I'll multiply it, I'll get what? 2x minus 3 minus 1. So 2 into x minus 2 is less than 4. I can cancel x minus 2. So now because x minus 2 lies in the denominator, I need to remember that x should not be equal to 2. So now if I'll solve it, I'll get what? I'll get under root of 2x minus 3 plus 1 is less than 8. Under root of 2x minus 3 is less than 7. If I'll square, I'll get 2x minus 3 is less than 49. X is less than 26. So answer to this question is the value of x should be greater than or equal to 3/2. Value of x should not be equal to 2, and then value of x should be less than 26. So final answer to this question is x belongs to included 3/2 to not included 2 union not included 2 to not included 26. So that's the answer to this question. The root of x plus 2 minus under root of 5x is greater than 4x minus 2. So now here again, I'll multiply both sides with under root of x plus 2 plus under root 5x. Now because this expression contains two positive square root, this is always positive, so sign of inequality doesn't change. So if I'll multiply it, I'll get x plus 2 minus 5x, and this is greater than 4x minus 2 into under root of x plus 2 and plus under root of 5x. So if I'll solve it, I'll get what? I'll get minus 2 minus 4x is greater than 4x minus 2 into under root of x plus 2 plus under root 5x. Now I can take 2 minus 4x on the right hand side. So I can simply write this as I can write this as 0 is greater than 4x minus 2. So I'll take 4x minus 2 common, and here I'll get under root of x plus 2 plus under root of 5x and then plus 1. Now this expression under root x plus 2 under root 5x plus 1, it is always positive. So I can remove it from the inequality. So if I'll solve it, I'll get 4x minus 2 should be less than 0. X is less than 1 by 2. So answer to this question is x is less than 1 by 2 provided conditions of domain are satisfied. So what are the conditions of domain? So conditions of domain are x plus 2 should be greater than equal to 0 and x should be greater than equal to 0. So x is greater than equal to minus 2 or x is greater than equal to 0. So here I'll get x is greater than equal to 0. So if I take the intersection of these two conditions, answer to this question is the value of x should lie between 0 and 1 by 2. 0 included and then 1 by 2 not included. So now when I see any under root expression, first thing I'll do is I'll find its domain. So condition here will be x square plus 4x minus 5. It should be greater than or equal to 0. So I'll get x plus 5, x minus 1 should be greater than or equal to 0. So this is what? Minus 5 and then 1. So it is plus, minus and plus. So either x is less than minus 5 or greater than 1, both included because there is an equality sign. Now on the left hand side, I have this expression which is x minus 3. So I need to take two separate cases. Case 1, when x minus 3 is actually less than 0, and case 2 when x minus 3 is greater than or equal to 0. So either x minus 3 is negative or x minus 3 is positive. So x minus 3 is negative when x is less than 3. So when x is less than 3, the inequality I have is x minus 3 is less than under root of x square plus 4x minus 5. So on the left hand side, I have an expression whose value is negative, and on the right hand side, I have a positive square root. So that means a negative expression should be less than a positive expression. So negative expression is always less than a positive expression provided the given condition. So I've got this result from the given condition which is x is less than 3. So from the first case, the solution I'll get is the value of x should be less than 3. The value of x should be less than 3. Now when x is greater than or equal to 3, now in this case, inequality is x minus 3 is less than under root of x square plus 4x minus 5. So now this is positive and right hand side is also positive. So now since both the expressions are positive, I can square it. So if I'll square it, I'll get x square plus 9 minus 6x, and it is less than x square plus 4x minus 5. X square will cancel. So I'll take 6x on the right hand side. I'll get what? 10x, and it should be greater than what? 14. X is greater than 7 by 5. So the result I've got is x is greater than 7 by 5. But then this result, it comes with the condition that x should be greater than or equal to 3. So I'll need to take intersection of these two conditions. So if I'll take the intersection of these two conditions, so first condition says x is greater than or equal to 3, and the second condition says x should be greater than 7 by 5. So x should be greater than 7 by 5. So intersection of both the condition is, so the intersection of both the conditions is x belongs to from 3 to infinite. Now because there is an or between the two conditions, so I need to take union of these two conditions. So union of these two conditions will be x belongs to, so from minus infinite to 3 union and included 3 to infinite. So now when 3 is included, I can simply say x belongs to minus infinite to plus infinite, provided it satisfies the condition of its domain. So final answer to this inequality will be the intersection of the given condition with the condition of domain. So if I take the intersection of these two conditions, the simple result I'll get is x belongs to minus infinite to minus 5 union included 1 to infinite. So the first thing that I'll do in this question is I'll find the domain of this function, and the domain of this function will be 2x plus 1 should be greater than or equal to 0. X is greater than or equal to minus 1 by 2. So this inequality is defined only when the value of x is greater than or equal to 1 by 2. Now about this 1 minus a, I need to know the sign of 1 minus a. So what I'll do is I'll take three separate cases. Case 1, when 1 minus a is equal to 0. Case 2, when 1 minus a is less than 0. And then case 3, when 1 minus a is actually greater than 0. Now when 1 minus a is equal to 0, in that case, I'll get 0 is less than 1. So it simply means it is true for all the values of x provided the conditions of domain they are satisfied. So in this case, answer is x should be greater than or equal to minus 1 by 2 when a is equal to 1. Now for the second case, when a is actually greater than 1, so in that case, 1 minus a is negative. So my left hand side is negative and right hand side is positive. Now negative number is always less than a positive number provided the condition of domain they are satisfied. So from second case also, I'll get the condition. So this is true when x is greater than or equal to minus 1 by 2. X is greater than or equal to minus 1 by 2 when actually a is greater than 1. Now when 1 minus a is greater than 0, that is when a is less than 1, in this case, 1 minus a is positive. So what I can do is, I can take 1 minus a on the right hand side. So I can simply write it as 2x plus 1. And this is less than 1 upon 1 minus. So now I can square it. So when I square it, I'll get 2x plus 1 is less than 1 upon 1 minus a whole square. Or x is less than 1 by 2, 1 upon 1 minus a whole square, and then minus 1 when a is less than 1. So answer to this question is x is greater than or equal to minus 1 by 2 when a is greater than or equal to 1. But the answer is x is less than 1 by 2, 1 upon 1 minus a whole square minus 1 when a is less than 1. So that is the answer to this question. So in this question, first thing that I'll do is I'll find the domain of this question. So for domain, so first condition I'll write 2 minus x should be greater than or equal to 0. That is x is less than or equal to 2. Second condition I'll write is for this square root, which is 1 minus x should be greater than or equal to 0. And that is x should be less than or equal to 1. And third condition, I'll write it for the square root, which is 4 minus under root of 1 minus x. So 4 minus under root of 1 minus x, this should be greater than or equal to 0. So under root of 1 minus x should be less than or equal to 4. So if I'll square it, I'll get what? 1 minus x is less than or equal to 16. So x is greater than or equal to minus 15. So if I'll take all the three conditions together, I'll get x should be greater than or equal to minus 15, but less than or equal to 1. So domain of this question is value of x should lie between minus 15 and 1. Now I'll solve this question. So I'll take it on the right hand side. I'll write simply 4 minus under root of 1 minus x is greater than under root of 2 minus x. And then I can square both sides. If I'll square, I'll get 4 under root of 1 minus x is greater than 2 minus x. So I can actually write it as 2 plus x is greater than under root of 1 minus x. In this case, I have an irrational expression on the right hand side and a rational expression on the left hand side. So I need to take two separate cases. Case 1, when x plus 2 is less than 0, and case 2, when x plus 2 is greater than or equal to 0. Now, when x plus 2 is less than 0, what I'll get is, so when x plus 2 is greater than, when x plus 2 is less than 0, what I'll get is left hand side, which is negative, is greater than right hand side, which is positive. So in this case, I won't get a solution. So that means this condition, I won't get any result. Now when x plus 2 is greater than or equal to 0, so now I have 2 plus x, which is greater than 1 minus x, and both of them, they are positive. So I'll square it. If I'll square it, I'll get what? 4 plus x square plus 4x, and this is greater than 1 minus x. So I can simply write it as x square plus 5x plus 3, and it should be greater than 0. So now when I'll solve this condition, I'll get minus 5 plus minus root 13 by 2. So I'll take a number line, I'll write both the solutions. So minus 5 minus under root 13 by 2 minus 5 plus under root 13 by 2. So rightmost is plus, plus, minus and plus. So either it is less than 5 minus root 13 by 2 or it is greater than minus 5 plus root 13 by 2. But then this result, it has come with the condition, and the condition is x should be greater than or equal to minus 2. The minus 2 will lie here, right? So this is minus 2. So when I take the intersection of these two conditions, result I'll get is x should be greater than minus 5 plus under root 13 by 2. So now I need to take intersection of this result and the domain. So I need to take intersection of these two conditions. So when I take the intersection of these two conditions, the result, the final result that I'll get is the value of x should be greater than minus 5 plus under root 13 by 2, but less than or equal to 1. So that is the answer to this question. First thing again that I'll do is I'll find its domain. So I'll let the condition for x plus 1. So x plus 1 should be greater than or equal to 0. That is x is greater than or equal to minus 1. I'll let the condition for x plus 3. So x plus 3 should be greater than or equal to 0. X should be greater than or equal to minus 3. And I'll write the conditions for x square plus 4x plus 3. X square plus 4x plus 3 should be greater than or equal to 0. I'll get x plus 1. X plus 3 should be greater than or equal to 0. So I'll write this is minus 3. This is minus 1. So this is plus, minus and plus. I need plus. So either less than minus 3 or greater than minus 1. So now if I'll take the intersection of all the conditions. So now in order to solve this question, I need to realize there is some symmetry in this question. So if I'm going to multiply these two, I'll get x square plus 4x plus 3. So what I'll actually do is I will let under root of x plus 1 plus under root of x plus 3 as y. So if I'll square it, I'll get what? I'll get x plus 1 plus x plus 3 plus 2 into under root of x square plus 4x plus 3 is equal to y square. So I can write 2x plus 2 under root of x square plus 4x plus 3 as y square, and I can take this 4 on the right hand side. So y square minus 4. So this actually is your left hand side. So I can write this as y square minus 4 is less than 3 y minus 2. So the result I'll get is y square minus 3y plus 2 is less than 0. So this is what? This is 1 and then 2. So plus, minus and plus, I need minus. So the condition I'll get is value of y should lie between 1 and 2. Now I can put the value of y and then solve the question. Now we know that domain of this function is x is greater than or equal to minus 1 and the value of y should lie between 1 and 2. And y is given by under root of x plus 1 plus under root of x plus 3, and this value should lie between 1 and 2. Now when x is greater than or equal to minus 1, then x plus 3 is greater than or equal to 2. So that means under root of x plus 3 is always greater than or equal to under root 2. So essentially under root x plus 3 is always greater than 1. So for this part, this is true for all x greater than or equal to minus 1. Now for the next part, what I'll do is I'll write it as under root of x plus 3 is less than 2 minus under root of
x plus 1. Now if I'll square, I can write it as x plus 3 is less than 4 plus x plus 1 minus 4 under root of x plus 1. So which is, so if I take it on the left hand side, I can write it as 4 into under root x plus 1 is less than 2, or under root of x plus 1 is less than 1 by 2. So if I'll square it, I'll get x plus 1 is less than 1 by 4, or x is less than minus 3 by 4. So the condition that I've got here is x should be less than minus 3 by 4, and the condition of domain is x should be greater than or equal to minus 1. So if I'll take the intersection of these two conditions, the condition I'll get is the value of x should lie between minus 1 and minus 3 by 4, minus 1 included and minus 3 by 4 not included.